Hello, good evening all. Can you hear me?
Yes, ma'am.
Yes, madam. Good evening.
So let's start the class now. So I've also posted the link in this chat box. You can go there and just click the link. Okay. So I will wait for like 2 minutes and then we'll start. So all those people who are here, please go to joinpd.com and use this code. Please go to joinpd.com and use this code. Others who have not joined it, please go to joinpd.com and use this code. Okay, let's start the class then. All right. So the first question that we have here is, suppose X is normal with mean mu and variance 4, and for 100 IID samples of X, the observed sample mean is 11.8. What conclusion would a z-test reach if the null hypothesis assumes mu equals 10 against the alternative that mu is not equal to 10? Okay. So there are many options here from 1 to 9. You have to select the options that are relevant to this problem. For the fz value, please use the online table, okay? Or if you need the values, let me know.
Ma'am,
Yes.
what is FG inverse of 0.9? Like 0.95, it is 1.65. So
Uh,
what is FG inverse of 0.9?
yes, I will write it in the chat box.
Okay, ma'am. Thank you.
Okay, so everybody did the problem. I could see 7 responses here. Should we discuss the solution? Hello?
Yes, ma'am.
Okay, so it's already been like 15 minutes. So but let's see the solution now. 2, 5, 6, 8, 7, and 9. So most of the answers I could say is 4, 5, 8, 9. Okay. So let's see what is going to be the answers for this. Okay. Now, what does the question says? It says you have a random variable x that is normally distributed, and it has mean mu with variance 4. Right now, you have taken from x, you have taken 100 IID samples of x, and from those samples you have observed that the sample mean comes out to be 11.8. So what conclusion would a z test reach if the null hypothesis assumes mu equals 10 against the alternative that mu is not equal to 10? So first of all, is it a okay? So you have to choose the correct options from the following. So first of all, what kind of test is it going to have? Is it a right tail test? You see that the null hypothesis is mu equals 10 and the alternative is mu not equal to 10. So is it a right tail test or left tail test or a two-sided test?
Sided, ma'am. It is not equal to 10.
Yes, and it is clear for everybody that it is a Z test.
Yes.
It is already given in the problem, so no issues. But even if it would not have given in the problem, still you are testing for mean and the variance is known to you, so you are basically using the Z test. Okay, now it is clear that it is a Z test and the two-sided test. Now what test statistic are we going to use? Is it a proportion p or is it a sample mean?
Ma'am, we didn't get it. What are you saying, ma'am? Left test. It's not clear.
No. I am saying, so we saw that this is, see, the null hypothesis was mu equals 10. Okay. Alternative was mu not equal to 10.
Yeah.
So it is not a right tail test, not a left tail test. It is a both-sided test, right?
Two-sided.
Like if you, if you draw the normal curve, then at both the ends you are going to have a tail. That is where you are interested in. Okay, so this is a both two-sided test. Now what test statistic are we going to use? So the first option says the statistic used is p, and the second option says the statistic used is sample mean. So you have two options here.
Sample mean.
Sample mean, right? You have the sample mean already given to you, so you can use the statistic sample mean. You cannot use the proportion because you have no idea like what is the observed value and all that. Now you have.
Ma'am, can you say an example where you're using a test statistic as P?
Okay, so in the coming examples that will be there in the slides, you will come across some examples where using the test statistic to be P. Okay.
And ma'am, what
What is
the
the
conditions
difference?
for a Z test?
Sorry.
What will be the conditions for Z test?
Conditions for Z test is you should be testing for mean and the population standard deviation should be known to you. So here you are testing for mean, right? You are testing if the null hypothesis is mu equals 10. And the population standard deviation is already given to you. That it is given in the first line that x is normal with mean mu and variance 4. So standard deviation is given to you already. And you are testing for mean. So basically this is a Z test.
Okay, ma'am. Thank you.
Now we have to check whether are we going to accept our H0 or we are going to reject our H0 at alpha 0.05 and alpha 0.10. Okay. So from the options, we could see that the correct answer is 2 is correct and 5 is correct. Okay. Now we have to check from 6, 7, 8, 9, which one is correct. All right. So since it is a two-sided test, you know that, okay, it is a two-sided test. We can use the test as reject H0 if X bar minus mu mod greater than C, where C is the critical value. See, you can also take the test statistic to be X bar minus mu. It is not an issue. Okay. Now the test says reject H0 if mod of X bar minus mu greater than C, where C is a critical value. I hope you have solved such kind of problem in the sessions before. Two-sided Z test. Have you solved it?
Yes, ma'am, we have solved that. Ma'am, can we use that reject H0 when mu is equal to 10? That is what, sir, I think I remember sir has explained like that, I guess.
Reject H0 if mu
Yeah,
equals
correct.
10.
Yeah, when mu is 10. Yes, yes. Yes, yes, it is written about. Yes, ma'am, it is there here. Reject H0 when mu is equal to 10, accept HA when mu is not equal to 10. Correct, no, ma'am?
Except HA when mu is not equal to 10. I didn't get what you're trying to say. So we have defined the null and alternative. Now we are going to check whether at our significance level, that is given to be in the first case 0.05 and in the other case it is 0.10. We are going to check whether we are going to reject the null or we are going to accept the null, right? This is what we are trying to do.
Okay, ma'am.
So, yeah. So, all right. We have defined our test to be reject H0 if mod of X bar minus mu is greater than C, where C is the critical value, right? Now we are using the test statistic to be X bar, and we know it is normal with mean mu and variance 4/100. So all that should be clear to you, that X bar is normal with mean mu and variance 4/100, right? Okay, so let's use what is the definition of alpha. So alpha is a significance level, right? And it says probability that you reject your H0 given H0 true. So when the mean was 10, okay, and like when the actual mean was 10, but still you are going and rejecting the null hypothesis. So that is the case when you're going to reject the null hypothesis in this situation, when mod of X bar minus mu is greater than C. So after this, what we will do, we will try to normalize this random variable, right? So to normalize it, we already have this X bar minus mu, just we need in the denominator, we need the standard deviation of X bar. So the standard deviation of X bar is, you see from here, so in the last line, we know that the variance of X bar was 4/100. So the standard deviation is going to be 2/10. So that's what we have done here. So we are dividing our X bar minus mu by 2/10. And same thing we'll have to do on the right hand side with the critical value. So this mod of X bar minus mu divided by 2/10, it becomes mod of Z, correct? So probability that mod of Z is greater than 5C. Okay. Now, if you draw the normal curve, okay, so what reason are you going to cover? So what does it mean by like mod of Z greater than 5C?
Some constant value at left side and right side of the mean.
Yeah, right. So on both the left side and the right side, like both the tail, you are going to have some area there, right?
Yes, ma'am.
Right. So basically it is trying to say that probability that Z is greater than 5C plus probability that Z is less than minus 5C, correct?
Yes, ma'am.
And you know that in the normal curve, like normal curve is symmetric around your mean.
Yes. So that will
So-
be equal probability.
So that will be equal. So we can just simply take 2 times probability Z less than minus 5C. Is the step clear to everyone? The third step here. Is it clear to everyone? Why is it 2 times P Z less than minus 5C?
Ma'am, why is it minus 5C?
See, look at the second line here. So in the second line, it comes out to be probability mod of Z greater than 5C, right? So if you break this, you will get probability Z greater than 5C plus probability Z less than minus 5C. Wait, let me share my screen and I will draw this out.
It will be very clear, madam. Like
I will draw
minus
it out.
5C is less than or equal to Z is less than or equal to 5C. If you write it, I think more clear.
So we had probability that mod of Z greater than 5C. Okay. Now, you know this Z is a standard normal random variable. So it will have mean at 0 and standard deviation 1. So this is at 0. Okay. Let's split this part inside the bracket. So it says probability that mod of Z greater than 5C. So it will become Z greater than 5C and it will have minus Z less than 5C. So this second term becomes Z less than equal to minus 5C. Okay. So now you have Z greater than 5C and Z less than equal to minus 5C. So let's plot this on this graph. So, okay, this is going to be your 5C. And since this is a normal curve, it is going to be symmetric around the mean. So both this area is going to be same, right? Z greater than 5C is this. And Z less than minus 5C is going to be this. And since it is a standard normal distribution, you know that this area and this area is going to be same, right? So if let's say if alpha was, if I'm saying alpha is 0.05 and it is a two-tailed test, then this area and this area combined is going to give you 0.05. So individually, so this is going to be 0.025 and this is also going to be 0.025. Okay, the same thing we are doing here. So if you have to find probability mod of Z greater than 5C, it means we have to find, we can just double this area, right? We can just double this area and we are going to get the overall shaded result, right? Is that right?
Ma'am, your volume is decreased suddenly.
Yes.
Ma'am, your voice has decreased suddenly.
My voice is decreased.
Very feeble, man.
Okay, so what I was saying is it okay now?
Very low still, man. Still very low.
What about now?
Yeah, ma'am, now
Better, better.
It is better?
Yes,
Yes.
yes, much better, man.
Okay, so what I was saying is now we have probability that mod of Z greater than 5C. What we did is this inside the bracket part, we split into two parts. So it became z greater than 5c and minus of z greater than 5c, right? So if you take this minus sign on both sides again, so it becomes minus z becomes z and 5c becomes minus 5c. And you know from maths that if you change the sign on both sides of the inequality, your inequality sign also changes. So since we have made this minus z, if we have multiplied on both sides by minus of 1, then the inequality sign is also going to change. So minus of z greater than 5c becomes z less than minus 5c. So now we have this z greater than 5c and z less than minus 5c. Okay. This is the standard normal distribution z, right? And it has mean with mu as equal to 0 and variance as 1. If we try to plot this 5c and minus 5c, so this is going to be the points, right? And now we need to find the probability that z is greater than 5c, that is this shaded area on the right hand side, and z less than minus 5c, that is going to be the shaded area on the left hand side, correct? So from the symmetricity of this curve, we know that this area is going to be the area on the right hand side, correct? And how will you find this area? We can write this as fc of minus 5c, right?
Yes.
So if you have to find, so it's not just this, you also have to add this area, correct? So how we can do it? We can just simply double it. If we can double it, you know that both areas are same. If you double it, you will get both these areas combined, right?
Ma'am, the way you wrote for the left hand side, fg of minus 5c, right? So for the right hand side, it will be 1 minus fg of 5c, right?
For the
Right hand side, it will be 1 minus
it will be
fg
1
of 5,
minus 1
fg
minus fg of
fg of 5c.
5c, right?
5c.
Yeah, 5c.
Yes. So if I club both these two, ma'am, yeah, if I club both these two, ma'am, then how I am coming at 2fg minus 5c. Okay. Could you please explain that?
Okay, so this area is going to be fc of minus 5c, okay?
Plus
And this area is going to be 1 minus fz of 5c, right?
Yes, ma'am.
So, okay. Now I will, fc of a, okay? fc of any a where a is a positive integer, okay? How can you write it? Let's say this is our minus a and this is our a. Now I'm talking about any general a. So fc of a, okay, you can write this as you can write this as 1 minus fc of minus a.
Or left hand side.
Wait. Fc of a is let's write it fc of minus, fine, fc of minus a. So fc of minus a this is right.
Ma'am, it should be plus a, ma'am.
fc of minus a is 1 minus
1 minus fc of a.
Yeah, this is plus only. I have made it plus.
Yeah, correct. Ma'am.
Yeah. So fc of minus a. So basically, let's see this. So fc of minus a. This is going to be 1 minus fc of a. So fc of
A, if you look at it, right? So fz of A is going to be all this area. Okay. And if you subtract it from 1, you will get fz of minus A. Right?
No, ma'am, I will get right hand side. I will get plus A.
You didn't get right hand side.
I will get right hand side now because I am subtracting 1 minus fg of A. Fg of A means
Wait, let me draw another graph. Wait. So this is a standard normal distribution. Let's make it minus A, and this is A. Okay. So let's say I'm interested in finding fc of minus A, or you can say so by symmetricity we know that this area is going to be equal to this area, right?
Yes.
So to find, let's say to find this, I can simply write it fc of minus A.
Yes.
But if I have to write this in terms of fc of A, how will I write this? Okay. So you have to find this area, and this area is going to be same as this area, right? So this can be written as 1 minus fc of A. So if you can subtract everything like till here, wait. So fc of A, you know, is the whole this part, right? This is fc of A. Fine. Is this it? This is fine, right? This whole red area is fc of A.
Yes.
And if you subtract this from 1, you will get
Right hand side.
right hand side.
Yes, ma'am.
So we can use this property, that is fc of minus A, that is equal to 1 minus fc of A. So what can you write? If what can you write my fc of A as? We can write this as 1 minus fc of minus A. Right? It is clear, right?
Yes, ma'am. It's clear.
Now the same thing. So if you have written it like that, you can just interchange.
Can you just go back?
Yeah.
fc of A. I'm not clear. I'm not able to align on this one. The first line is okay.
Which first line? This
Second
first line? Second.
Yeah, that's okay.
You mean this line? I have
Yeah,
just
second line.
I have just taken this fc of A on the left hand side of the equation. So since this was in minus sign, it will come to the right and left hand side, and it will become plus sign. So fc of A becomes 1 minus fc of minus A. It is just equation, simple equation. I haven't done anything here.
Okay.
Okay. So what I have said.
What are we trying to reach over? No. What are you trying to reach here? You said that shaded portion, the tail portions are both are equal.
No, what are we trying to, like, how to get to this? Like, how do you write fc of minus A in terms of fc of A? This is all we are trying to do.
Oh.
Okay. So we wanted to write fc of minus A in terms of fc of A, or fc of A in terms of fc of minus A. Both sides. Okay. Now, since we had fc of minus 5c plus 1 minus fc of 5c, and from here we saw that fc of A can be written as 1 minus fc of minus A. So fc of 5c can be written as 1 minus fc of minus 5c, right? This is from here. So you just substitute this fc of 5c here. So it becomes fc of minus 5c plus 1 minus one minus fc of minus 5c. Okay, and it becomes 2 times fc of minus 5c. You don't even have to do all this. You can just simply find this from the using the symmetricity of this curve. This is much more complicated. I mean, there's nothing complicated here, but still you are doing some extra steps.
But we can simply take 2 times fc of 5c.
Yeah, that's
instead
what
of
I'm
minus.
saying. Yeah, that's what I'm saying. You can we know that these are symmetric. This area and this area is going to be same. So you can just simply take 2 times fc of minus c.
Or plus 5c also you can tell, no?
No, plus 5c you cannot tell. So if you take 2 fc of plus 5c, you will be taking this whole area, this whole thing till here 2 times. But this is not we are interested in. We are interested in this tail areas, right? See, this shaded region on the green, this we can write it as 2 times fc of minus a. But this is not equal to 2 times fc of a.
Isn't it 2 minus 2 fc of 5c?
Sorry, 2
minus 2 fc of 5c.
2 minus 2 fc of
5c.
5c. So you are saying it is 2 times 1 minus fc of 5c.
Yeah.
So this is 2 times fc of minus 5c.
Right.
Yes, this is fine. This is fine. But you have to keep, like, be careful. Like, this 2 fc of minus a, fc of minus 2 fc of minus a is not going to be equal to 2 fc of a. Okay, because you will be saying that 2 fc of minus a, you are only taking these tail probabilities. You are actually calculating these probability. But when you talk about 2 fc of a, you actually take all this, like from here till here, right? You are calculating this 2 times. That is wrong. Is it clear?
Yes, ma'am.
Okay. So let's
Yes,
move
ma'am.
back. Okay, so let's go back to the question again. So in the question, it was given that we had to find probability mod of z greater than 5c, right? We had to find probability mod of z greater than 5c. And this is what we drew the graph, right? So this was f0, this was 5c, and this was minus 5c. So this we can write it as 2 times fc of minus 5c, correct? And this was given to be 0.05. This was our significance level. And now we have to solve it for critical value, right? So how do we find it? So we can write this as 0.025 equal to fc of minus 5c. And this 0.025 is actually minus 1.96. Okay. And this is going to be minus 5c. So c becomes 1.96 divided by 5. So what is 1.96 divided by 5? It is
0.39.
out to be 0.392. And the test was reject H0 Okay, reject H0, and H0 was mu equal to 10 and HA was mu not equal to 10. So reject H0 if mod of x bar minus mu comes out to be greater than C. Okay. So given this is true, given this mu equals 10, your x bar minus mu is what? What was x bar? I think 11 point something.
11.8.
11.8, right? 11.8 minus this 10, if you do,
1.8.
so you will get 1.8, and it is going to be greater than C, right? So you are going to reject your H0, right? So the same thing you are going to do for significance level 0.10, the same calculation. Okay. So this we have done. You can try for the significance level 0.10.
Ma'am, can I ask a question?
Yes.
Ma'am, we started off with the test that x bar minus mu should be mod of x bar minus mu should be greater than C.
Yes. The
Now,
first
what-
line here.
Yes, ma'am. What if we start with just x bar, mod of x bar greater than C? What's wrong with that? I don't know.
Mod of-
Mod of
okay.
x bar greater than C. I mean, I'm getting
See.
the same result here.
See, mod of x bar minus mu, if you do mod of x bar minus mu, so you are bringing it to the standard normal form, like the mean you are taking it to 0, and once you are dividing it by 2 by 10, you are making the standard deviation to be 1 basically. So you're normalizing it.
And do the same thing with the mod of x bar greater than C, no, ma'am? Like you are dividing it by with the standard deviation.
Okay. If you don't do, you can also do it like that. So if you don't take minus mu here, you just take mod of x bar greater than C given mu equal 10, right?
Yeah, ma'am. So that later on I don't have to do that minus thing. I can just
I
get the
will-
result straight away.
Sorry.
I can compare. I get C and I just compare with 11.3 and get it done. I don't have to do a subtraction over there.
It is also fine. No issue.
Okay.
Ma'am,
ma'am.
Sorry.
why don't we
What is
subtract,
the sorry?
why don't we subtract mu from C like we do in other cases?
Because here you have already taken the mu for x bar minus mu.
So we should do it from the other side also, right?
No, you don't have to do it from the other side. Like making it like subtracting it from mu, you are already bringing your this random variable to the whose mean should be 0. So you don't have to subtract it again. So
Ma'am, we have to subtract it if we take x mod of x bar greater than C. Then we have to subtract it. Once we are like
in that
normalizing it.
case, you will have to subtract it. So let's do wait. First, let's finish this. Wait. So you got reject H0 at 0.05. So option number 9 is correct. And you will also get reject H0 at alpha 0.10. So at both the significance level, you are going to reject your H0. Okay. For 0.10, you can try it on your own. And let's look for when we take the test to be mod of x bar greater than C, then what happens in that case? So if we write 0.05 equal probability mod of x bar greater than C given mu equal 10, okay? Then in this case, it becomes probable, this mod of x minus you're subtracting mu, right? And this is C minus 10 divided by, so it becomes 5, 1 by 5, okay? So basically this is probability mod of Z greater than 5 times C minus 10. All right. And this becomes FZ of minus 5 C minus 10. Okay. And this is 0.05. And it becomes 1.96 minus 1.96. So minus 5 times C minus 10. From there you get C to be equal to 1.96 divided by 5 plus 10. So what does this value comes out with? 1.95 divided, sorry, 1.96 divided by 5 plus 10. This comes out to be, C comes out to be 10.392. Okay. Now X bar we have observed to be 11 point something. I don't remember it. Okay. And so this mod of X bar comes out to be greater than C. So we are going to reject our H0. Right. So both ways we are going to get the same answer. It just the critical value is going to change. So in this case, the critical value is 10.392. And in the other case, the critical value had come to be 0.392.
Ma'am, shouldn't that be like, since it's not equal to and rather than not greater than?
Sorry?
Shouldn't that be like mod of X is becoming 11 point something, but that's not equal to C. Like we are testing absolutely bang on for equal to C, aren't we?
Yeah, this is absolutely greater than C, right? X bar is coming, X
No,
bar it
I
was.
mean, had we got some value that was less than C, we would have still rejected it. Don't we? I mean,
No, we did not get a value that is less than C. We got the value that is like this value was given to you in the problem, right? X bar was given. What was the value?
11.8.
11.8, right? Now this mod of X bar is nothing but 11.8, correct? And this you are getting to be greater than C, and C was coming out to be 10.392. So anyways, X bar is going to be greater than this C. So you are going to reject H0, right? Reject H0 at alpha equals 0.05.
Got it. Thank you.
Yeah.
But
Ma'am, I
ma'am,
have
why is so much confusion there? Why is not one step followed everywhere?
See, whatever is your convenience, you can do it. It's not a problem. Okay.
Okay.
Ma'am, I have a doubt. Instead of finding probability of mod X bar minus 10 greater than C, can we find that significant level is mod X bar minus 10 less than C?
Okay. So why not less than C? Okay. Let's see it here. So you're saying mod X bar minus mu less than C. Okay. So if you write this, should I write it straight or is it fine?
It's fine. It's fine.
So if you do probability mod of X bar minus mu greater than C, oh sorry, less than C. Okay. What are you going to get from here? So at mu is your mean. This is the distribution for your X bar, right? This is a distribution for X bar. Mu is the mean. And if you break this, right, you are going to get, this is mu plus C, and this is going to be mu minus C.
So the X bar lies between mu minus C and mu plus
X bar
C.
lies between this.
Right.
So are you going to take your significance level, which are like, if you write this, you are actually going to get this probability, right?
Right.
But what exactly is significance level? The value, the point at which you are going to reject the null hypothesis, probability of making the type 1 error.
Right.
And if it is a left tail test or a right tail test, right? So basically this comes out to be your significance level. you try to reduce your significance.
Okay,
right?
okay, I got it. Yeah, I got it. Yeah.
All right.
So ma'am, basically, if we take less than C, we are reversing the rejection zones. Is that what you're saying?
Yeah, you are saying that this is your acceptance. Sorry, this is your rejection reason.
Okay. Thank you, ma'am. Got it.
But this is your acceptance set. Here you want to accept, not reject.
Thank you.
Yeah. Okay. Let's move to the next problem now. Okay. So here, this question says, it is claimed that the lifetimes of light bulbs are normally distributed with mean of 100 hours and a standard deviation of 2 hours. So again, you have a distribution that is normally distributed. Okay, so let's say X denote the lifetime of light bulbs. Okay, and if this random variable represents the lifetime of light bulbs, which is given to be normally distributed with a mean of 100 hours and standard deviation of 2 hours, we wish to test the hypothesis that mu equals 100 against the hypothesis that mu not equal to 100 with the sample size of 9. Find the significance level if the acceptance reason is 98.5 less than equal to X bar less than equal to 101.5. Okay, so here 98, this is your acceptance reason. So if your X bar lies between 98.5 and 101.5, we are saying we are going to accept the hypothesis. If this is our acceptance reason, in this reason you are going to accept. So what should be the significance level if you are taking a sample of size n?
Madam, just a quick question. Or rather, I need some clarity on one of the
Yes.
concepts. Maybe in the
Okay.
meantime, can I ask that? What is the relation between type 2 error and power, madam?
Type 2, so type 2 error is equal, power is equal to 1 minus type 2 error.
Okay. Now,
Yeah.
when we are writing the probabilities for these, type 2 error is probability of acceptance of H0 when HA is true. Is that correct?
Yeah, so like if like it is given that like when the alternative hypothesis is true, but still you are going to go and accept the null hypothesis, right? So by doing this, you are making an error and you want to reduce this error, correct?
Right. And
what is, and power of the test is 1 minus beta, right?
right.
And so this is defined as like given the alternative is true, still given the alternative is true, you are going to accept the alternative. This is power of the test, and you want this power to be as big as possible.
Then why do we write it as reject H0 when alternative is true? Okay, because we're accepting the alternative, is it? Okay.
Yeah.
So power is
Reject H0.
Reject H0 when alternative is true. Okay. Okay.
Yeah.
Thank you. Thank you, ma'am. And in problems related to proportion, when I say P is, let's say 0.6, my variance is 0.6 into 0.4 if it is a binomial. Is that the way I should take it?
We'll discuss this, okay?
Okay, all right, thank you.
Thank you.
One more question related to the earlier one, madam. Earlier problem, rejecting H naught when significance is 0.05. If that is the case, if I actually make the significance 0.1, it still is going to be rejected, isn't it?
Yeah, it is still going to be rejection.
Mathematically itself, the line comes a little further towards the mean.
The line come further towards the mean.
I mean, the line which is defining my critical value.
Okay.
Does it come towards the mean or away from the mean, madam? I'm under the
Is it
impression
coming towards the mean, right? It is coming towards the mean.
Towards the mean, right? Yeah. I just want confirmation on that. Yeah. Okay.
Okay.
So if it is for 0.05, we already determined it is going to be one case. It remains the same for any higher values. That can be a thumb rule, right?
Sorry, can you repeat?
It will be a thumb rule if I increase this significance at, let's say, 0.05 is determined the situation. So if I increase the significance value, the situation doesn't change. At least when
still you are going to reject it.
Yeah. Okay. All right. Thank you.
Yeah. Yeah, so let's look at the responses now. Okay, from here it is not possible to check. All right. So the null and alternative was given, and the acceptance reason was given, and we had to find the significance level, right? So how will we find this? This all information is given to us that let's say the random variable x denote the lifetime of electric bulbs, and it is given to be normal with mean 100 and standard deviation 2, right? We have taken a sample of size 9, and the null and alternative is defined in this way, where h naught is mu equal 100 and alternative is mu not equal to 100. So how do we find alpha? That is significance level. It is probability of rejecting H naught given H naught is 2, right? So rejecting H naught is going to be your sample mean. If we are taking our test statistic to be X bar, so X bar should be greater than 101.5 or X bar should be less than 98.5 because this was our acceptance reason, correct? Like between 98.5 and 101.5, this was our acceptance reason. So anything beyond this, like anything less than 98.5 or anything greater than 101.5, it is going to be a rejection reason. So if we are taking our test statistic to be X bar, it is going to be X bar greater than 101.5 or X bar less than 98.5. So basically this can be written as mod of X bar minus 100 greater than 1.5. Is it clear till here, till third step? Till third step, is it clear?
Yes, ma'am.
Okay. So whatever we have done previously, the same thing we are going to use. So this, we have to divide it by standard deviation now. So if you divide it by standard deviation, it is going to be 2 divided by 3 because the standard deviation was 2 and n was given to be 9. So it becomes 2 by 3. Same thing we are going to do on the right hand side. It becomes 1.5 divided by 2 by 3. And if you solve it, it comes out to be mod of z greater than 2.25. And after that, it becomes 2 times fz of minus 2.25. And this value was given to you in the problem. So solving this, it becomes 0.0244. So this is a significance level you are going to get. Okay. This is clear, right?
Yes, ma'am.
Okay, so let's move to the next problem now. It's the same problem, except that in this case, you have to find the power of the test against the alternative that the true mean life is 103 hours. Okay. So alternative is given to you, that is 103 hours. Now, what is the power of the test?
Madam, can you mention the range of operation once in this model?
What?
The range that was there as the limits, not the limits, the positive and the negative.
Okay, it was 101.5 and 98.5.
101.5. Okay.
Yeah. 101.5 and 98.5.
Ma'am, what does against the alternative mean?
When you find the type 2 error. So basically, what is type 2 error? Like given the alternative is true, okay, you
Yes.
are going to accept H naught.
Yes.
Right? Given
Yes, yes.
alternative, you know that alternative is true, you are going to accept H naught.
Yes.
So what do you mean by alternative true? Here, like you have a composite in the hypothesis tested, that alternative hypothesis, you have composite hypothesis, right? No, it is not a simple hypothesis.
Yes.
So if we are writing mu not equal to 100, okay, it can be anything. We don't know what actually it is.
Yes.
Right? So you need a particular value of mu, right? You need a particular mu for which you can actually test this. You actually find this error. Yeah. So this is what is written against the alternative. So let's say now your alternative is 103. So when the alternative is 103, what is the probability that you are going to accept H0? That is type 2 error. All right.
Correct. Yes.
Yeah. Okay, so let's see the answer here. Okay. So here we had to find the power of the test against the alternative that the true mean life is 103 years. Okay. So you know that the power is 1 minus beta, and it says given alternative is true, you are rejecting H0. You should reject H0, right? So this rejection reason is, again, we know it is x bar greater than 101.5 or x bar less than 98.5, right? And in this case, mu is given to be the alternative hypothesis, that is mu given to be 103. Okay. So once we solve it, we get this to be probability mod of x bar greater than 101.5 given mu equals 3 plus probability mod of x bar less than 98.5 given mu is equal to 103. Fine. Now separately we are going to solve it, and we will get probability z greater than minus of 2.25 plus probability of z that is less than minus 6.65. So this, you know that the second part, probability z less than minus 6.75 is going to be close to 0, right? This probability is so less, so this we can neglect, and we will have just left probability z greater than minus 2.25. Okay, so this becomes 1 minus fz of minus of 2.25, and this is almost equal to 0.987.
So again, in this problem, we're looking at what is between the limits on the curve, is it, madam?
What is between the
Limits, like what is the area that is lying between 98.5 and 101.5 with the mean shifted to 103?
with the mean shifted to 103? Yes. So is this clear? Like, how did we find the power?
Yes, ma'am.
Clear.
Ma'am, the expression is clear, ma'am.
Okay.
Ma'am, just a small doubt. Like whenever mod z is coming, right? So we are using that formula that 2fg of c, right? So in that case also, can we break like this and use this? Can we break like this the way we have done in problem number 3?
Okay. So here also you can do probability mod of x bar greater than 101.5 given mu equal 100, right? Plus
Yes,
probability x bar less than 98.5 given mu equal 100. You can do it.
I can proceed in that way also, right?
Yes, yes, you can proceed. You will get the same answer. You try
Yes,
it
yes.
on your own. Okay?
I got it, ma'am. That's what I'm asking.
Yeah.
It is by fluke or it is.
Okay.
Can you go to that question, the one that we saw just now?
You mean the question?
Question number 3.
The solution, ma'am. The solution part.
The second part. Okay. Yeah.
Yes, ma'am. Ma'am, I have a question. This is that like which Kangapasad just asked. It said like taking an x bar minus 103 greater than 3. Where am I going wrong with that?
100 and sorry, x bar minus 103.
We are rejecting h0 when h is true, right, ma'am? So
we are rejecting h0 when h is 2, right?
So, ma'am, if we write mod of x bar minus 103, like
okay,
we are taking that has to be our sample mean. Now the true mean is given as 103, but HA is true means that 103 is now the mean, right?
103 is given to be mu, right?
Right, ma'am. Because we are, I mean.
So okay, so you are saying why can't we write this as mod of x bar minus 103 greater than?
Simply greater than 3, ma'am, because we are taking a population mu of because we are rejecting h0, aren't we?
No, you are saying that why are we not writing the second step?
I mean, my question is, where am I going wrong?
No, yeah, so you are going you are saying you have written the after the second step as probability mod of x bar minus 103 greater than 3.
Yes, ma'am.
Okay, so why have we written it greater than 3?
Because ma'am, the mean the sample mean is given as 100.
Okay.
So hence I'm taking like my left hand side of the inequality becomes my z. So I'm left with 3 by the standard deviation, that is 2 by 3. Where am I going wrong, ma'am?
Okay, so if you are writing mod of x bar minus 103 greater than 3,
Ma'am,
right?
I'm sorry to interrupt, ma'am. We can take this up at the end also. Like I don't want to delay the session.
Okay, I will take it at the end then.
Thank you so much.
So once again, madam, graphically, if we have to put it, it is going to be the area within the limits, correct? I'm trying to solve the problem. I'm trying to understand.
Yeah, area between the limits. Yeah.
There's one of the problems, a similar one in the just a minute. It's not in the graded assignment, but it's basically week tutorials. There it is shown as subtracting for whatever reason. I'm just trying to.
Subtracting what?
Yeah, just give me a second. I'll pull up the problem and I'll tell you which one it is. Perhaps if you can.
Okay, so that also will take it at the end. Okay.
Yeah.
Okay.
Okay.
Yeah?
Sure.
We'll continue
tutorial,
this.
Yeah, tutorial 1, problem 8.
Tutorial 1, problem 8. I will write it down.
Yes, madam. For some reason, there is a subtraction there, and that threw me off actually.
Okay. All right. So, okay. Here the question says a commonly prescribed drug for relieving the nervous tension is believed to be only 40% effective. Okay. To determine if a new drug is superior in providing relief, suppose that 100 people who were suffering with nervous tension are chosen at random and inoculated. If more than 50 of them are found to be relieved, we reject the null hypothesis that P equal 0.4 and the new drug will be considered superior to the one currently in use. Okay. So there is a drug that is believed to be relieving the nervous tension only 40% of the time. Okay. And we want to check like whatever new drug we have introduced, whether it is superior. So if you give that drug to the person who are suffering with this particular disease, so how much effective it is, you want to check that. Okay. So using this, you are taking the null hypothesis to be 0.4. And you have to first of all decide on what is going to be your alternative hypothesis, what is going to be your test statistic, what is going to be your test. Then find your type 1 error and then find your type 2 error for P equal 0.6. So there is also one hint given here, like you use normal approximation to binomial.
But ma'am, what is C in this case? Critical value.
This is given in the problem itself. You have to say it properly. Okay. You can write your answer in the peer deck, Atul. If you're not on the peer deck, you can write your answer there. Do not write your answer in the chat box.
Okay, ma'am.
Yeah. Okay, so let's look at the answers here. Oh, here it is not possible to write 2 answers too, right?
That's why when I did right.
Yes,
Okay,
ma'am.
okay,
Yes,
yeah.
ma'am. It is not possible to write two answers.
Yeah, I got it. Okay. So, okay, the first question here, the null was given to us. So the null was p equal 0.4. What is the alternative hypothesis?
Greater than 0.5. P equal to greater than 0.5.
Greater than 0.5.
0.4.
Just a
Greater
second.
than 0.4.
Sorry,
right?
greater than point. Sorry, ma'am. Greater than 0.4. Yes, yes. I have written greater than 0.4.
So since you wanted to check that this new drug that has been introduced, whether it is working better or not. So you want your P to be greater than 0.4 because initially it was 40% chance. So you want this chance to be more. So this P should be, alternative should be P greater than 0.4. Okay.
But ma'am, it's written if more than 50 of them are found to be relieved, we reject the null hypothesis.
Yes.
How can we take it like less than anything less than 0.5?
Anything less than 0.5. We are not taking anything less than 0.5.
No.
Ma'am,
what I'm
actually,
trying
I
to
also
say
got
is-
confused by that statement
Okay,
only,
see,
ma'am.
if more than 50 of them are found to be relieved, we reject the null hypothesis.
Yes,
Okay.
it means alternate is
So-
correct.
No. So, the test, what does your test, if you try to define your test, it will become reject null if x bar is less than c, right? Some critical value. Correct? So here, what does it say? We reject the null hypothesis if more than 50 of them are found to be relieved.
So ma'am, like if more than 50 of them are found to be relieved, but reject H naught if X bar is more than 0.5.
Yes. So basically the critical value is given to you.
Yes, that's 0.5. That's what I'm saying, ma'am. Like we can reject
Yes.
the null only if X bar is greater than 0.5.
Yes. Reject null only if x bar is greater than 0.5.
So it means alternate is greater than 0.5.
So you have to find the type 1 error and type 2 error here. So all this you already know, right?
No, ma'am, if you can kindly explain, like I really got stuck in handling those, conversion of from Bernoulli to binomial.
Okay.
Which can spend a minute on.
So, so null was given to be 0.4, alternative was given to be greater than 0.4. Okay, alternative become p greater than 0.4. Critical value is c, like if we not say it from the fraction approach. So critical value is c, and the test statistic t, we can take it as binomial 100 comma p. Okay, so you have a total of 100 people who has on which the drug has been tested. Okay, so n is 100, and there is some probability p that we do not know, right? And out of these 100, we said if more than 50 are relieved, then we will reject our h naught. Okay, now if we do this normal approximation to this binomial, we know that if we can approximate the binomial distribution with n comma p as normal with mean np and variance npq, right? So np becomes 100p and np 1 minus p. So 100 times p into 1 minus p. So this is the normal approximation that we have done here. Okay. Now we have to find what is type 1 error. So type 1 error, we know it is probability that t is greater than 50. So you write C here, like basically in place of 50, generally we write C, but in this case, we know what is the critical value. So we can write probability t greater than 50 given t equal 0.4, right? So if you want to convert this t to this normal form, you'll have to subtract the mean. So the mean is 100 times p. So 100 times 0.4 divided by 100 times 0.4 times 0.6, right? So this becomes 1 minus fz of, if you solve this expression on the right hand side, it becomes 2.04. So this probability of type 1 error is coming out to be 1 minus fz of 2.04. And fz of 2.04 is given to be 0.979. So type 1 error is 0.021. This is a type 1 error. Similarly, you can find a type 2 error. So type 2 error is what? Given your alternative is true. So here the alternative was given to be p equal 0.6. So given your alternative is true, you are going to accept h0, right? So accepting h0 means t should be less than equal to 50, because you were rejecting your h0 when t was greater than 50. So you will accept your h0 when t will be less than equal to 50, right? So again, the same thing, you will convert this to the standard normal form, and it will become fc of minus 2.04, and this will come out to be 0.02.
Ma'am, in the square root at the bottom, we have is that standard deviation, right?
Standard deviation, right?
So we will not be taking root n.
Okay, here root n is not needed.
That has already come in NP2.
No, this looks like the CLT wala form.
Yes, it is that only. Everywhere, whatever is you are using is that same thing. In this case, you are saying it looks like this Sn minus n mu divided by under root of n times sigma.
Yes, ma'am. Yes, ma'am.
Right? Yeah, this is kind of the same. So you are getting both this type 1 error and type 2 error to be equal. That is 0.021.
So type 2 error is beta, right? Probability of type 2 error is beta.
Yes, probability of type 2 error is beta. Is this question clear?
Yes, ma'am. So what are the conclusions we draw from this? What were we asked? What was asked in the problem?
In the question, it was asked to find the type 1 error and type 2 error. That's it. So generally, you have seen the significance level or the power is given to you, and then you are trying to find your value of n or your value of c. But here the c was already given to you, right? C was already given to you. So given that C, what is the type 1 error? This is what you are trying to find.
And ma'am, like if we
what should you take your significance level to be?
Got it, ma'am. I'm just asking, like, what do we do now? Like, did we reject the hypothesis or accept it? Like, I'm not getting clear on that.
Okay, so here we did not ask you whether you are going to accept or reject, but still you can check this. So your null was, see, your null was p equal to 0.4 and alternative was p greater than 0.4, right? And
but ma'am, the alternative was p greater than 0.5. I mean, must that always be equal? Like,
sorry?
H naught, if we have H naught as p equal to 0.4, can't we have an alternative hypothesis as p greater than 0.5?
Ma'am, that
but null is 0.4, right?
Yes, ma'am. So, I mean, what I'm asking is that, like, is there a problem if we have a null as p equal to 0.4 and the alternate as p greater than 0.5?
And could you please come to question, because that state I am also confused.
You will
with that
have, you will end up
statement.
with the gap between 0.4 and 0.5.
Yes, because
Your
this
continuity
statement,
will not be there for the area.
if
So
more than
P
50 of
value
them are
should be
found to be
same.
relieved, right? So this statement is making some confusion. I also wrote, alternate more than 0.5.
Alternate or sorry.
Yeah.
Alternate P equal to more than 0.5. I also wrote because of this statement. If more than 50 of them are found to be relieved, we reject null
See,
hypothesis.
what? Okay. In the question, you have to check that a commonly prescribed drug for relieving nervous tension. So there is some drug that is believed to cure the disease by only 40% chance. There is only 40% chance that it is effective. Okay. Now some new drug has been introduced and we want to check whether this new drug works better. Okay. So initially our belief was that P is 0.4. So we want to check that whether P is greater than 0.4, right? This is what we want to test, that P is greater than 0.4 or not, correct? Now, so we got our null to be 0.4, P equal 0.4, and our alternative to be P greater than 0.4, because this is what we want to check. Now to check this, what has been done is some 100 people who actually had this disease. So those people were given this drug, the new drug that was introduced. So for those 100 people, you gave that drug, and if more than 50, it is written that if out of these 100 people, if more than 50 gets relieved from this medicine, then we will reject the null hypothesis. Okay, and we will consider that the new drug that we have introduced is superior, right? So if you just look at the null and alternative, okay, so given this null to be 0.4, P equal 0.4, and alternative to be P greater than 0.4, okay, so if you had to design a test, so how will you design this as? You will use the test statistic to be, you can use it as sample mean, right? Or you can use it as, let's say, x1 plus x2 till x100, right? That also you can use. So, and the test is going to be reject your H0 if your test statistic is greater than some critical value. Okay. So if your test statistic comes out to be greater than some critical value, then we will reject that H0. All right. So here this critical value is already given to you. So out of this 100 people, if we find this, if we find more than 50 people to be relieved, then we reject the null hypothesis. Okay. So if I take, let's say, the test statistic to be sample mean, right? Then this test is saying that I will reject H0. Test is saying is that I will reject H0 if this X bar is greater than 0.5. This is my test going to say. Reject H0 if X bar is greater than 0.5.
So 0.5 is becoming C.
So 0.5 is becoming C. So this is the critical value, after which we are going to reject the null. So for this critical value, what is going to be the type 1 error, or what is going to be the type 2 error? Right?
Okay.
But ma'am, I asked this, like, had the problem been asked just to, let's just say if had the critical value had not been given or something, and we had to came across a critical value of 45, let's just say, which is more than 40 and between 50, what would we have done?
Okay, if you are saying this was not given, so if it was not given, it means you're saying if the critical value is 45, this is the only thing that is given.
I'm saying that, like, just say that we have done the previous problems, like, right now, like whether to accept or reject a null hypothesis. Let's just say the problem comes out like that. And in this particular problem, like there's a condition that 50 of them are found to be relieved, then you're going to reject the null.
No, it is not if 50 are going to be found relieved. It is saying if more than 50 are found to be relieved, then we reject the null hypothesis.
Yes, ma'am, that is given for this problem. What I'm trying to say is that if we say calculated the critical value and found out, see, the critical value comes out to be 45 or something, what do
Okay.
we do?
Okay, so if critical value comes out to be 45, and if in place of more than, if the sample mean is 50, if we are saying that the sample mean is coming to be, if the total is coming out to 50, or if x bar is 0.5, if this is what is observed, if x bar is 0.5, that is what it is observed, and if the critical value comes out to be 0.45, right? This is the question. Then will we reject or accept the null hypothesis? This is what you're asking.
Yes, ma'am.
Right? So, okay. So the test says we reject the null hypothesis if this x bar comes out to be greater than c. So here you can see that this x bar, that is 0.50, this is what we have observed. So this 0.50 is coming out to be greater than 0.45, right? So you are going to reject the null. You are going to say that this the drug that you're using previously is
Yes, exactly,
not,
ma'am.
yeah.
The point being is, in that case, can we write that P, the alternative hypothesis as P A? I mean, our alternative hypothesis as P greater than 0.4. Should we write that P greater than 0.5? That's what I was trying to say.
Why do you want to write P greater than 0.5? We are writing our P to be 0.4, right? And we want to check whether the new drug is better than the previous one. So the previous one, it was only 40%. So we want our new drug to be more than 40%. We don't want it to be greater than 50%. We want to check whether the new drug is greater than 40%. This 50 is, this is what you have observed, right? After giving the drug. But before that, you did not know that it is going to come to be more than 50. You just want to check whether the new drug is superior. So you want to check whether the new drug is more than 40% effective. So P should be greater than 40%. P should be greater than 0.40 in your alternative.
May I say what I understood, madam, so far from your explanation? So basically, when we start, we have a drug which is 40% efficient.
Right.
So that is what we are accepting. That is a null hypothesis. So the alternate is it not being 40% efficient. Whether it is more or less, we'll come to that later. First thing is it is null is 40% efficiency. Alternate is not 40%. But when I go down there in the problem, there is a statement which says if more than 50 of them are found to be relieved. So I take my critical value as 50%. And hence I check for the greater than. Is that correct? Is that a correct interpretation?
No. See, in the second sentence, it says to determine if a new drug is superior.
Superior. Okay, sorry.
Yeah.
I missed that part. Sorry. Now it is clear. Now it is clear. Now it is clear. Yeah. Because it is superior, it has to be more than 40%. Yeah.
You want to check that it is more than 40.
So that's the reason why my alternate is more than 40%. Got it.
Yeah.
Yeah. Thank you. Thank you.
Is this problem clear now?
Yes, ma'am.
And if the critical value,
Sorry, can you repeat again?
if the critical value is 0.3, what will happen to the result?
If critical value is 0.3, what will happen? You can check here, right? You can, so you can find type 1 error, and in place of 50, you just write 30 and see what is going to be a type 1 error.
But there is also an observation to the question on what the gentleman has asked. It is no longer superior.
It is no longer superior. Yeah, because we are saying reject H
Then
not
accept
if T is
the null
greater than.
hypothesis.
Yeah, then accept the null hypothesis.
No, we can't, right? If it is reducing in efficiency, null hypothesis is also wrong. no longer valid, isn't it?
No,
No,
that
no.
will be
So
correct, na?
if we are saying the critical, like if critical is 30, okay, if you are saying the critical value is 30, and we are saying reject H0 if this test statistic T comes out to be greater than 30. But
Greater than 30, yes. Yeah.
but our previous drug was actually 40% effective.
Okay, on that basis. Okay, superiority of the drug is no longer there, but yeah, got it.
Yes, we have to accept null hypothesis.
Yeah. No, we have to reject the null hypothesis that it is 40% effective. It's only 30% now.
No, you have to accept the null hypothesis.
So you're saying if in place of if more than 50 of them are found to be relieved, we reject the null hypothesis.
Right.
But it doesn't make sense, the statement. Like
So,
we are saying that even if 30 of them, or let's say 35 of them are found to be relieved, we are rejecting the null. But then what is the chance that it is superior than the previous drug? It is possible that it may not be as effective as the previous one. Then if we are rejecting null, we are again doing a mistake there. So that probability, that is alpha, you should try to make it as low as possible. So it is possible that if you take 30, you get your alpha to be too high, but we don't want it.
right.
Yeah.
So, ma'am, here also the test statistic is mean, sample mean.
You can take test statistic to be sample mean. No
Not
issue.
P, right? So it's not P.
Here we are not taking it as P. It is sample mean.
So when do we take the test statistic as P?
Test statistic to be P.
Ma'am, isn't this not P?
This is P only actually, because out of you're saying out of 100 more than 50. So let's say if it is 50, basically you want to check if P is greater than 0.5. That is nothing but P. I mean, if you look at it as like
Ma'am,
each of
can
the
you put it
person
graphically?
graphically.
Yeah.
Oh, okay.
So here P and X bar are same.
Yeah, kind of P and X bar is
Yes,
giving
ma'am.
you the
P and
same
X bar
value, right?
comes to be the
So
same thing.
basically, if I'm writing X bar, it means we are trying to say that this is equal to X1 plus X2 plus up to X100 divided by 100, right? And each of the Xi is Bernoulli. It is correct? So this will give you nothing but P, like out of 100 people, so X1 plus X2 plus X100 is going to give you like how many are found to be effective, right? And this is nothing but P. Right? So it depends on how you are defining your random variables. And in the
That part I didn't understand. We are checking if P X probability of X bar greater than C. So the test bar, the test statistic is X bar, right?
you can also write it as P. It's not an issue. You can write it as P hat or something. It's just a way of denoting whatever is happening. Just a way of notation. So, like the problem that we saw there, we have defined it as test statistic to be x1 plus x2 plus up to x100, right? Because we had written this t to be greater than 50, and this t is nothing but like sum of all this. Like this x1 represent the first person, the x2 represent the second person, right? So basically, either each of them are either going to be 0 or 1, because it is everything is Bernoulli. All these xi's are Bernoulli, and this you are writing it as t. So here in this case, the test statistic is x1 plus x2 plus up to x100. I'm writing my test statistic to be this. Also, we could have written this t to be p hat, or let's say this is also, if I'm representing this xi's to be Bernoulli 0, to be Bernoulli p, okay, if I'm presenting this as Bernoulli p, then this is also same as x bar, which is p hat. You can write this. It's just a way of denoting things. Then in that case, your mean would have been x bar, mean would have been mu. So that is p, right? You write the mean to be p, correct?
Okay.
And standard deviation to be p times 1 minus p divided by n. This is what you write to be standard deviation, right? But if I have to write the mean here, so what is the mean here? It is n times p, right?
Okay.
So 100 times p, and the standard deviation we write it as 100 times p times 1 minus p.
Right.
Right?
Right.
So you can use anything, but you'll get the same answer. When it's a different way to write things, but it represents the same thing.
Okay.
Okay. So about the graph for the previous question, so we wanted to check whether p is 0.4, whether p is greater than 0.4, and the c was coming out to be 0.50. Okay, and we were saying if this x bar comes out to be greater than this, we are going to reject null. So this is your alpha, and we wanted to find this probability. That's it. Okay, it's already 10:05. Let's do one more problem. Okay. Okay, again, this is a problem of same kind. Okay, so there are two problems. Which one do you want to see? I think this is almost same what we have done just now.
If it's the same, let's do the other problem, madam.
Yeah, so it says, the question says the proportion of adults living in a small town who are college graduates is estimated to be p equal 0.4. So this is what has been estimated, that is p is 0.4. And you want to test this hypothesis against the alternative that p is greater than 0.4. To test this, you decide to take a sample of adults from the town. So given the null was 0.4 and alternative to be greater than 0.4, you are taking a sample of adults from the town. Now, what sample size do you need for a test against an alternative p equal 0.6 at a significance level 5 and power 95%? So here the significance level is given to you, the power is given to you, and alternative hypothesis is given to you, then you just have to find what sample size do we need for the test such that our significance level is 5% and power is 95%. And in the second question, you have to find what is the critical value at a significance level of 5%. Okay.
We have to use the n which we got in question number 1, right?
Sorry, we have to find.
We have to use the sample which we got in question
What?
number
Yes,
1.
sample size and yeah, that we
And-
have to use to find the value of C. So again, the null and alternative is same as what we have seen in the previous question. Alpha is 5%, power is 95%. Okay. Test statistic, we can define it as T to be binomial NP, and if we approximate it to normal, it will become normal NP, comma NP times 1 minus P. And if we take our test statistic to be X bar, it becomes normal with mean P and variance P times 1 minus P by N. Now the test says reject H naught if X bar is greater than C. Okay. To find N, since you know what is significance level, we are using the formula, right? And we are getting this expression at the end for critical value. So C is coming out to be under root of 0.24 by N, FC inverse of 0.95 plus 0.4. Similar thing we are going to do for power. We know power is 0.95, it is given to us. And it is defined in this fashion that given this alternative is true, we are going to reject here H naught, right? We know how to solve such kind of problem. And again, from there, we got a critical value C that is going to be under root of 0.24 by N, FC inverse of 0.05 plus 0.6. So you have two different expressions for this critical value C. One is FC inverse of 0.95 plus 0.4 and other is FC inverse of 0.5 plus 0.6, right? Now you have to solve these two equations. If you solve these two equations, you will get N something similar to something closer to 65. And once you put the 65 in the first equation, you will get your critical value. So you're getting a critical value to be 0.49.
Ma'am, only one doubt, ma'am.
Yeah.
Like in previous question, when we approximated it to normal, binomial to normal, then we use a formula that normal NP comma NP 1 minus P, right? But I think here in first slide we use normal equal to P comma P into 1 minus P by N, right?
Yes.
So both are okay?
Both are okay. Both are okay. So what I would suggest is like such kind of problem we are using the proportion. You try to take you try to solve first by using the test statistic to be binomial NP and the other one to be the sample mean where it is approximating to normal P times P 1 minus P by N. Another to be normal NP times 1 minus P. Both will give you the same.
Second option is more suitable because we are habituated like this now.
Okay, so you use it the second one. It is fine. So basically, solving both alpha and beta, you will get two different equations, and once you solve that, like you solve both the equations and you get the value of N, and you substitute this N in any of these equations and get the critical value. So here it has been specifically asked for at a significance level of 5%. So we substituted in the first equation. Is this question clear? Like the method is clear?
Yes, ma'am. Just upload the slides today itself.
We'll send
tomorrow
it.
Or tomorrow morning at least.
By tomorrow morning it should be done.
Yes. We can go through this.
Okay. So let's look at the next problem. It says a survey of 200 randomly selected students from a school revealed that 70% of them participates in extracurricular activities. Okay. So this is from like whatever sample you have taken. So sample of 200 students you have taken. And from there you had observed that 70% or P equal 0.7, like 70% of the students take part in extracurricular activities. This has been observed from the sample. Okay. So can we conclude at 5% level of significance that 80% of the students participate in the extracurricular activities?
And so null is 0.7, right?
Okay, so we don't have much time. I would
Yes,
just
we can discuss quickly.
discuss side by
quickly.
side. Yeah.
Yes, yes, sure.
So, okay. So the question says, can we conclude at 5% level of significance that 80% of the students participate in the extracurricular activities? So what is the null? The first question. What is the null hypothesis?
0.7.
Okay.
0.7.
Anybody else?
0.8.
Okay. Anybody else?
0.7.
0.8 is the null hypothesis.
Okay, so 2% is saying 0.7, 1 person is saying 0.8.
0.8 the null hypothesis.
0.8 is the null hypothesis. Okay. Any other answers? Okay, so here the null hypothesis is P equal 0.8.
Why so, madam?
Okay, so see, on the left hand side, it is written that a survey of 200 randomly selected students revealed that 70% of them participates in extracurricular activities. So this is what has been observed from the sample. Okay.
Okay.
You had taken a sample of 200 students, and from there you found that out of these 200 people, 70% of them are going to participate. They participate in extracurricular activities. So this is something like observed value, right?
Okay.
And the question asks, can we conclude that 80% of students participate in the extracurricular activities? So basically we want to check that whether this proportion is 80 or it is not 80, or this 0.8 or not 0.8.
So it is more like 80 is the claim that we want to verify.
Yes.
So ma'am, what is the alternative hypothesis? Is
Not
it
equal,
not
not
equal
equal
to?
to.
So the null hypothesis, you want to check whether this proportion is 80%. So
0.8,
this
yes.
proportion is 0.8, right? So the null hypothesis is P equals 0.8 and the alternative should be P not equal to 0.8, because you just want to check whether this proportion P is 80% or not.
And then what is critical value here, ma'am?
Critical value is not given here.
Okay.
So how do we go about, madam, when we say we go for the mod now, then
Is the significant level given?
Yes,
that
it is
given
5%.
5%.
oh, okay,
5%.
we
So-
find the critical value. Okay.
Okay, wait. So I will just write it down. So we got our H naught to be, we wanted to check whether this P is 0.8 or not. Okay.
This is a two-tailed test, ma'am.
This is a two-tail test. Alpha is given to be 0.05. N is given to be 200, right? And 70% is what we had observed. Now, what does alpha means? This is probability that mod of x bar minus p is greater than c, given p equals 0.8, right?
Yes, and null is true.
When null is true. So if you make this convert to mod z, this is going to be c divided by under root of 0.8 times 0.2 divided by 200.
Yeah.
Fine. And this becomes 2 times fz of minus c minus,
c minus mu we have to do, na?
sorry?
Greater than c, so we have to do c minus mu, something like that.
No, we have already
No,
taken
not
this
this.
mod of
Okay.
x bar minus p. Okay. So minus c divided by 0.16. So we can write this as 0.4 divided by under root of 200.
That is 1.64 minus
So it becomes 0.025.
0.025. Sorry,
So
that's
minus 1.96
Yeah.
equal to minus c divided by 0.4 times under root 200. Right. So c comes out to be 1.96 times 0.4 divided by under root of 200. Okay. So what is this 1.96 times 0.4 divided by under root of 200? It comes out to be 0.055. And what is x bar minus p? So x bar was 70 divided by 200, right?
Yeah. Yeah.
And p was 0.8. So this value will come out to be 0.45. So this mod of x bar minus p is coming out to be 0.45. That is greater than this c. We are not doing any calculation mistake, right? So far, I don't know. So we got this mod of x bar minus p to be greater than c. So we are going to reject our h naught, and we are going to conclude that this p is different from 0.8.
Okay.
And some doubts are there.
It is
The values are widely different now.
Whenever we standardize our test
so
statistics,
this is actually not 70 by 200. This was 0.7 because out of 200
70%.
people, 70%
so
are 70%
So 140,
are
that will be 140.
0.1 and that is 0.1.
so it is going to be 0.1.
Still greater than, yeah. It's still greater.
Still greater than C. Yeah. So we are going to reject H naught. So what was the doubt?
And that was, a very small doubt. Like whenever we are standardizing my test statistics, right? So like we write alpha equal to probability, or there only, man. Just go back to that slide, man.
Okay.
Yeah, here itself, like when we write x bar minus mu divided by square root of variance, right? So we subtract something from C also, right? But here we are not subtracting anything from C.
Because here you are already doing x bar minus p, means x bar minus mu.
But the same will get subtracted from C also, no? Generally, in all cases, we have subtracted from C also. In all cases, like whenever we have written T is greater than C, whenever we have written T is greater than C,
you can do it. Then in that case, what you will do is you will write your alpha to be probability mod of x bar greater than C. Okay.
Yes.
Given mu equals mu naught. Okay.
Yes.
Then in this case, you will subtract mu naught from both the sides.
Yes, that's what I'm asking.
Yeah, in this case, you will subtract.
And will divide by variance.
Yeah, But if you are writing alpha equal probability mod of x bar minus mu naught greater than c, so here you have already, why we are not subtracting here by mu naught, because you have already standardized this random variable x bar, and not standardized, like you have already made this mean to be 0. So you don't want to subtract another mu naught from C. Like we had already seen here, no? Like two different problem with the same problem with two different approach. When we took in one case, we took our sample test statistic, like test to be reject H naught when x bar minus mu greater than C, and other we took reject H naught when mod of x bar greater than C. Both case, you are going to get the same value, same answer. It is just the way how I have defined my test to be. I can define it like this, I can define it like this. It's completely your choice what test, like what do you how do you want to define your test to be. Okay. All right, so any doubt in the problem we just discussed?
Can you calculate the power of test now?
Power of the test.
Yes.
So power is 1 minus beta, right? And it says probability of rejecting H naught given null is true, given H equal, given mu equal mu naught. Sorry, rejecting H naught when alternative was true. So HA is true.
Yes.
Right? So let's say if my null hypothesis is mu equal mu naught and alternative hypothesis is mu greater than mu naught, okay? Let's like take it like this. So
hello.
And yes.
Alternate was mu not equal to mu naught.
Okay, so you want it for mu not equal to mu naught?
Yes.
Okay. So now let's say the alternative that I have observed is mu equal to some mu A. Okay. This is what
That's
has
what
been
I
observed.
was asking now. We need to have some extra information about the alternate.
Yeah, because we are just saying given alternative is true, we want to reject H naught. So what is that probability? But if you see your alternative hypothesis, it just says mu should not be equal to mu naught. So what should you take mu to be? So what I'm saying is, let's take mu to be mu A. Then given this mu equal mu A, what is the probability that you are going to reject your H naught, right?
So we need to know the mu element.
Yeah, you need to know the mu A.
Okay, that's what I was asking.
Yeah.
In this question, power cannot be calculated.
Power cannot be calculated by?
Because
just the above hypothesis.
Our
Let's say
alternate
mu
is
is
that is
equal
not equal to 0.8, right?
Sorry.
So
Can
we don't know alternate. No? It is alternate just that is not
there. Oh, for that question. Yes,
Yes,
there it is not possible. Yeah.
That's what I'm saying.
Madam, I have a small, I mean, like I just asked the question earlier, you clarified already, power and type 2 error. Normally, when you talk about type 2 error, I tend to calculate power and then subtract it from this one. So when you are writing it, we write it as accept H naught. In this case, if I write it as mu is equal to mu naught, when mu is equal to mu naught, then how do I actually compute it or put it in the formula? Like in the earlier problem also, the earlier problem where we computed the type 2 error, we just went about with C minus.
Okay, so wait, let's define a problem. So let's say I'm writing my H naught to be mu equal mu naught, HA to be, let's take it simpler, so mu greater than mu naught.
Yeah.
Let's take, I have taken a sample of n, I have observed some x bar.
Yes.
Okay, and I'm taking my, okay, this is not needed. So some alternative I am taking to be mu equal mu a, because we have to find power.
Okay.
So from power, we know that it is equal to 1 minus beta. And how it is defined is probability. You want the power to be maximum. You want to maximize this. So given this alternative is true, what is the probability of rejecting H naught? And you will always want this probability to be much bigger, right? So when are you rejecting H naught? Let's say I'm taking my test statistic to be sample mean and my test to be reject H naught is X bar is greater than C. Okay. So I am rejecting my H naught when X bar is greater than C. So probability of rejecting H naught, as that is probability X bar greater than C, given HA is true. It means mu equals mu A, right?
Yeah.
Now to find the power, you will have to convert this to Z form.
Yeah, that's clear. That's clear. Just one more extension. If it is alternate is mu is less than mu naught, then the same thing happens here. X bar is less
Same
than
thing
C.
happens here.
Yeah,
so X bar is less than C, right?
Yeah.
And this is when you reject H naught, and it is the same thing.
Yeah.
Okay.
Yeah. Madam, there is one sentence that is there in one of the problems in actually the graded assignment. I don't need the entire thing, but just wanted to understand. Use normal approximation to binomial. What does it mean, man? What should I do with that?
Normal approximation to binomial. So we have seen in two of the problems, even in this session.
Two problems. Yeah.
So when I was taking my test statistic to be x1 plus x2 plus up to xn, where each of these xi's are Bernoulli P, okay, then this T is going to follow a binomial distribution with n equal with number of samples within which is first parameter is n and second parameter is p, right?
Right.
Now, if you do the normal approximation to this, it becomes normal of with mean NP and variance NP1 minus P.
Yeah.
So basically NP is what? NP is the mean of binomial and NP times 1 minus P is the variance of binomial. So when n is much, like when n is larger, we can approximate this binomial to a normal distribution where this distribution will have a mean NP and variance NP times 1 minus P. This is what we mean by normal approximation.
Okay. But other way of looking at, I mean, what I was doing was P into 1 minus P is anyway the variance. By root n is something which I kept doing.
So it is not necessary that you do it in this way. You can follow that approach also.
Yeah, so it's basically
like your X bar becomes just normal with mean P and variance P times 1 minus P divided by n. This is also fine.
That's also fine. Yeah.
Yeah.
Thank you. And if you can spare a few minutes, can we go to the tutorial problem 8, madam?
Tutorial. Okay. Are you able to see the portal?
Yes, ma'am.
Okay. Tutorial 1.
Problem 8, if we start the solution itself, there the solution.
Okay.
Yeah, if you scroll down a little bit, please.
Okay.
Yeah, scroll down a little bit. Yeah, here probability of minus 4.8 less than or equal to z is less than or equal to 1.2. It is written as minus 1.2 here and subtracting fz of minus 4.8.
Okay. It is wrong. It should be fz of 1.2. Sorry.
Okay.
Oh, no. It is mistake on this side, like the last third. So it should be probability minus 4.8 less than equal to z less than equal to minus 1.2.
Minus 1.2. Okay.
Yeah.
Okay, that was the first part. And one of the problems, the computation requirement was for power, but the symbol was used as alpha. So that probably was a typo. I don't remember where I don't remember where I saw that. If you it's the same problem, madam. In the same problem, scroll up a little bit, please.
Okay.
Scroll up a little bit. The static. No, not that far. Not that far. A little down.
Okay.
Okay, there. We're computing type 2 error, and then alpha was written there. I just assumed it as a.
Okay. Yeah.
Type 1.
Yeah, it should be better, right?
Yeah. Okay.
Yeah. Okay. We'll try to change this. Yeah.
Yeah. That's all it was.
Okay,
Thank you.
okay. Thank you. Okay, is there anything else?
Somehow during the session, confidence is there, but out of it is a problem.
So you need, these are little different concepts that what we have seen before. So it will take time to get adjusted.
Yeah.
And did you find some time to check that, week 9 solve with us question number 1?
Solve with us.
Question number 1. You can post in Discourse also, ma'am, tomorrow. No problem.
Yeah, you have posted on Discourse or
no, I have not posted. I requested on that day.
Okay. So you can post on Discourse. That will be better. I will check and answer. Okay.
Okay. So
but please tag me there.
Yeah, the question is very simple that we have to find out the bias.
I remember. You
using
have
the formula square, square of error, expected value of square of error.
Okay, so what were you doing there? Expected value of theta hat minus theta whole square.
Both answers are not matching. Like we have followed the formula that risk equal to bias square plus variance, right?
Yes.
We are getting one answer, and the other approach is that risk is nothing but expected value of square of error. So both should give same answer, right? But it is not giving the same answer. Yes, square it. Expected value of square of error. Yes, correct. This is one way, right?
Yeah.
This is one way of finding risk, and the other way of finding risk is risk equal to
So
bias.
what were you doing here? Can you tell me?
I calculated error.
Okay.
And I squared them, and then I was trying to find out the expected value of that.
Okay, you just post it there on Discourse and I will look at it. Okay.
Please upload the slides tomorrow.
I'll give it today or we'll share it.
Then what is the final decision? Whether the deadline is tomorrow or we have extended the deadline?
We have extended the deadline, right?
Thank God.
Please check once.
Just a second.
So the deadline is 25. So it is day after tomorrow.
Okay.
Yeah.
Same thing for math also, I hope. No.
Sorry?
I was hoping math also would do the same, but seems like they didn't.
Okay. So week 11, week 12 goes in the same line. It should not be a problem.
Yeah, so now it is 25th. Yes,
so if you understand week 11 properly, it is very easy to go through week 12.
So now we are meeting on Tuesday, ma'am, right?
We are meeting on Tuesday. Yes. Okay. So yeah, good night, everybody.
Good night.
Thank you. Thank
Yeah,
you.
thanks.
Good night, ma'am.
Good night.